To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
So my dear children, in the earlier chapter, I have given you a brief introduction for the echoing thing, right? So we discussed that the thing called echo is getting generated because of the reflection of sound waves. So within this lesson part, within this chapter, we'll be focusing about how or what are the special things that is created mainly because of the reflection of sound. Okay, so under that, my dear children, we'll be mainly studying about the echo. So here we are going to study about the echo effect, right? So we discussed that the occurrence of echo is going to happen because of the reflection of sound. So to identify the echo effect, we are going to do an activity, a practical. So here within this practical, we'll be needing a clapper. This is the instrument which is called as the clapper, my dear children. So this clapper is used to, right, like in running events, in athletics, right, in order to give out a certain signal, a good heavy signal for the runners to start the race. This clapper is used. Okay, so we'll be needing a clapper, right? So here, my dear children, instead of clapper, you can use any other different object which can emit a heavy sound. Okay, this activity will not be continuing with this activity, my dear children, at our laboratory, because we won't be able to do this activity at the laboratory. Okay, here we have to go outside and find out a good obstacle. Then after that, we need to do this activity. So this is not an activity that can be conducted within the laboratory. Okay, so this is an outside experiment. So what you have to do, you have to find out a clapper, right, to generate a heavy sound. Then let's see what is the method. So method is given. Select a place where there is a suitable obstacle like a tall building or a wall. Stand about 17 meters apart from the obstacle. Minimum distance between the obstacle and the observer to hear an echo is 16.5 meters. So my dear children, minimum distance in order to experience the echo effect, right? The minimum distance between the obstacle, that means you know that sound is going to reflect and come towards another observer or whatever, right? Usually now we are the observer, we are the ones who are going to listen, no? So sound is going to travel by hitting on that particular place to a different other place. So we are going to observe from that place. So we are the observer right now. So what you have to do, you have to select an obstacle. So this obstacle is the one which is going to reflect the sound. And the distance between this obstacle and you should be greater than 16 meters. Okay. Now here it is given. You have to be at a place like around 17 meters apart from the tall building. Okay, or else from a wall. Right. So whatever the obstacle, you have to select the obstacle and you have to be at a place like 17 meters. Then what do you have to do? You have to operate the clapper. Okay. Now here it is given. Make strong sounds by striking the clapper several times and listen carefully. After each instance of making the sound, discuss the reasons for observations. Repeat the activity while coming closer to the obstacle. Make the sound while you are at a distance of 15 meters or less to the obstacle. You can use even the walls of your classroom for this. Now, what you have to do? First of all, we have to be like at 17 meters from the obstacle and we have to, strike the clapper and you have to listen the sound very carefully. right? Then my dear children, what do you have to do? You have to go like 15 meters apart. Then you have to strike the clapper and listen to the sound carefully. Okay, that's the way of doing. Then compare the latter observations with the earlier ones. So then you have to what do you have to do? You have to compare the observations from the later ones with the previous ones. Okay, so this is the way of doing the activity, my dear children. Okay, so like I said, I told you that we won't be able to do this thing at our laboratory, because you know that we have to find out an obstacle and we have to go like to a place like 17 meters over here. Then you know that it's quite difficult to continue this particular activity within our laboratory. So what you have to do is you have to go outside. Even my dear children, if you don't have a clapper, then you can use your hands to give a clap. Okay, a heavy strike or else a heavy clap can be made by even by your hands. What you have to do is you just need to find out a wall and stand like 17 meters apart from it, then clap and see what's going to happen. Then come near to the wall and clap and see what's going to happen. Okay, right? So this is very simple. Then my dear children, what will happen in here? It's very simple. When you are like 17 meters or greater than that, and when you are making the clap, you can hear the echo effect. You can hear the two sounds. One sound is the clap, which is getting emitted when you are clapping the clapper or as your hands. The other sound is the echo given out by that clap, which is going to hit on that particular obstacle and once again come back to your place. Okay, so you can hear two different claps at two different time intervals. The time gap is not that much, the time gap between these two sounds are not that much greater. But however, we can clearly identify two distinct sounds. Okay, that is the one which is referred as the echo then. The second sound is the one which is referred as the echo. However, my dear children, when you guys are going to move closer towards the obstacle, you won't be hearing the echo effect. It's because now you are not at a minimum distance to experience it, right? The minimum distance that should be, right, the minimum distance which the observer should be is around 16 to 17 meters. Exactly, it is like 16.5 meters. So if it is more than 16.5 meters, my dear children, then you can observe the echo effect without any trouble, right? So you have to be at least at 17 meters, greater than 16.5 in order to observe echo. So when you are moving forward, right, closer to the obstacle, you won't be listening or you won't be able to listen to the echo, right? You won't be able to listen to the echo. It's because, my dear children, now there is no minimum gap between you, which is the observer, and the obstacle. Okay, right? So this is our observation then. So here, when you move on with the next thing, you are given with the observation and the conclusion. So what is our observation? Observation is very simple. Two sounds are heard when 17 meters, when about, will mention as about, when about 17 meters away from the wall. This is the first observation. The second one would be two sounds are not heard two sounds are not heard when when less than 17 meters. When the gap is less than 17 meters, okay? When the gap between wall right, so here I have mentioned as the observer, okay? So two sounds are heard when about 17 meters away from the wall. Then two sounds are not heard when the gap between wall and the observer is less than 17 meters. So here the conclusion, two sounds which emitted, or else we can mention as the other sound, right? Other sound which heard is called the echo. Is called the echo. Echo is created due to reflection of sound waves. Right. So my dear children, this is the observation and our conclusion. So once again, two sounds are heard when 17 meters away from the wall. Okay. So second one, two sounds are not heard when the gap between wall and the observer is less than 17 meters. These are the two observations that we can take from the activity. You go ahead and do the activity, my dear children. By doing that, you also can get the same experience. Okay. The conclusion is, other sound which heard is called the echo. Echo is created due to reflection of sound waves. So due to reflection of sound waves, the other sound is getting created, which is called as the echo. However, my dear children, the two sounds are not heard, or the echo is not heard, when the gap between wall and the observer is less than 17 meters. So that means by doing this activity, we can come into a conclusion that in order to hear the phenomena called echo, there should be a minimum distance between the observer and the obstacle, right? Okay. So the echo, right? Let's see. Sound generates by the clapper was reflected by the obstacle. After hearing the first sound, the reflected sound was also heard after a short while later. So like I said, my dear children, after a short while later, we are going to hear the second sound. Okay. This is the reflection of the first sound. That's why we can hear the same sound once again. Next thing given, a second hearing because of the reflection of sound after the first one is known as echo. The second hearing, right? Second hearing of sound after the reflection of first one is known as the echo. Second hearing given by a sound source, right? Second hearing given by a sound because of the reflection of the first sound is referred as the echo. This is the one which is referred as the echo then. So when the obstacle is too close, the echo is not clear. this fact is confirmed in activity. So like I said, my dear children, we will not be able to observe the experience, we will not be able to observe, right, the experience of echo if the distance is less than 17 meters. I mean, if the distance is actually less than, not says 17, but exactly 16.5. So if the distance is less than 16.5, we won't be able to listen the echo. Okay, so there is a minimum gap, there should be a gap in order to experience the echo. So here, especially given when the obstacle is too close, the echo is not clear, we won't be able to hear the echo. This fact is confirmed in the activity, in the previous activity. We can confirm it by using the previous activity, you can confirm it. Then sometimes several echoes can be heard because of the reflection of the first sound. This happens when the sound is reflected several times. For instance, sound reflection in an auditorium can be mentioned. Now, my dear children, what will happen if the same sound is going to hit on different surfaces, and because of that, what will happen? These reflected sound waves once again coming back to our ears at different time intervals. Then, my dear children, we can hear different kinds of orals, different kinds of, it is not actually the different kinds of sounds. However, we can hear the same sound at different intervals. So within different intervals, we can hear the same sound repeatedly. Okay, this is also happening because of the reflection of sound. The echo itself is going to reflect once more and once again that is going to heard by us, or that is going to come to our ears, right? So in that case, several times over and again, we can experience the same sound. Okay, so this kind of a process, or this kind of a one, is somewhat disturbing for us. Actually, we won't be able to identify what are the things, or what are the information contained within the sound. So these things, I think you have experienced these things within auditoriums and in cinema halls mainly. Okay, especially in auditoriums, in larger halls, this phenomena is being observed. Okay, so over there, then what will happen? The sound will not create a sound which is getting created will not be clear for you. If it is giving out a certain information, then you won't be able to catch these informations clearly, right? So this is also a big disadvantage of echoing, right? Now this disadvantage is only observed in a certain places, my dear children. Not every place, but in certain places only, like auditoriums. Then, my dear children, we like cinema halls and so on. Okay, in larger closed areas like those things, right? Larger closed areas like those things, right? We can observe this several echoes which is going to happen at the same time. So in that case, we won't be able to identify the sound which is emitted by the sound which is given out by the source very clearly, because of that echoing process which is going to happen repeatedly. Okay, right then. So you're given with an assignment. List out the instances of sound reflection that you have experienced in your day-to-day life. Mention the obstacle that is responsible for the reflection of sound in each instance. Now what do you have to do? In day-to-day life, my dear children, you have to find out what are the instances that you can hear, right? What are the instances that you can hear this echo? Okay, and my dear children, you have to write down the obstacle as well. So like I said in the previous activities, in the previous assignments also, I'm going to do only two, or I'm going to give out only two examples. You should have to follow out these things and we have to do the rest. Okay, right now we'll write down two examples then. So a very simple, in a cinema hall. So in a cinema hall, we can experience this thing. The obstacle is walls, right? Walls are the obstacles. Then in the top of a mountain, then the obstacle would be another mountain. Right? Another mountain. Right? Another different one, not the one you are standing on, but the other one which is located somewhat far away from it. Okay? Right. So in a cinema hall, walls are the obstacles. Then, my dear children, in the top of a mountain, another different mountain is going to be the obstacle. Right? So these are some day-to-day these are some day-to-day examples where you can observe the echo. At these places, if you shout enough, then you can hear the echo without any trouble. Right. So I hope that you will find out even more information, even more good examples for this process of echoing. Okay. Right. Then try to find out the obstacle which the sound is going to reflect as well. Right. So this is the one, or this is the phenomena which is called as the echo, my dear children. Right. So about the thing that we discussed regarding the minimum distance. Now under the extra knowledge part, it is given. This is the one which I have told you at the beginning of our chapter, my dear children. I told you that in order to experience the echoing effect, there should be a minimum distance between the observer and the obstacle, right? Now the observer is the one who is going to emit the sound, no? So there should be a distance between the observer, that particular person, and the obstacle, my dear children. Okay. So when a certain person is going to make a sound, what will happen? That sound will travel towards the obstacle and hit on that particular obstacle and come towards once again him. So him or her, right? So by that way, him or the her or whatever the observer can hear the echo. However, my dear children, like I said, there should be a minimum distance. Now within this part, I'm going to show how to get that minimum distance. So for that thing, two different facts are very important. Let's see what are those two different factors then. So first of all, given here, though the sound is reflected, clear echo is not heard when the obstacle is too close to the observer. There is a minimum distance that should be maintained between the obstacle and the observer to hear an echo. That minimum distance can be calculated as given below. These are the two main important facts, my dear children. We already discussed these things. So the two main important facts. Number one, sense of sound is retained in human ear for about 0.1 seconds. What do you mean by that? Now when I'm going to speak a certain word, okay, word. So this sense means this sound, the sound sense. Okay. Now let's take one example. Let's take word. Now I'm telling the word called word. Now that word sound is retained in your brain for about 0.1 seconds. Okay. That sound is retained in your brain for about 0.1 second, my dear children. Okay. So the next one is sound travels 330 meters per second in air. So this factor we already discussed. Sound is going to travel like 330 meters within 1 second of a time period. Within 1 second of a time period, it is going to travel 330 meters. 330 meters. So these two facts are very important in order to calculate the minimum distance in order to experience the echo. Now we know that I told you that the sound sensation of a certain sound is going to retain in our brain for about 0.1 second. The other important fact is that sound is going to travel at 330 meters per second within 330 meters per second, right? That is the speed of sound in normal air. Okay, right, now let's see. Then the next important fact, to distinguish two sounds separately, difference between them should be more than 0.1 second. Now my dear children, in order to observe, right, in order to observe that there are two different sounds, the first sound, or after the emission of the first sound, the second sound should come at least after 0.1 second. The minimum time interval should be at least 0.1 second. That means as soon as the first sound, sensation of first sound is going to release out, the second sound is should come. That's the minimum distance. That's the minimum time taken, right? So in order to observe as two different sounds, the gap between two, right? The gap between two sounds should be greater than 0.1 seconds. Okay, the gap between two sounds should be greater than 0.1 second, at least 0.1 second. That means as soon as the sensation of the first sound is going to disappear, the second sound is going to come. In that case also we can, right, like nearly we can catch up with the two sounds. Okay. Now my dear children, if not, you won't be able to experience the echo. So the minimum distance can be calculated then as follows. Let's see. The distance that the sound travels in 1 second is equal to 330 meters. This is the idea of 330 meters per second thing. 330 meters per second thing is that it is going to travel 330 meters within 1 second of a time period. Next one, distance that sound travels in 0.1 seconds then. So within 1 second it is going to travel 330 meters. Then the distance traveled within 0.1 second is equal to this particular example. See, 330 into 0.1 over 1 second, right? That means for 1 second 330, then when you multiply by 0.1, you can find out how much is the distance which is going to travel within 0.1 second. So it is equal to nearly 33 meters. So this value is not the exact value, my dear children. Normally, that is the normal average speed. Normally, it is going to travel around 330 meters per second. So these values are average. So here 33 meters is the distance. So total distance that the sound should travel to occur an echo. So the sound wave which is going to emit by me now should travel and hit another different obstacle, and once again it should come to me in order to give out an echo. So the sound wave should travel like 33 meters from here to there, then there to here. So both of these journeys together creates about 33 meters. Okay. Then to find out the distance between the obstacle and the observer, what do you have to do? You just take this 33 and divide it by 2, because you know that sound is going to travel 2 times from here to there when we are observing an echo. Right? When I am going to clap, the sound of the clap is going to travel towards the obstacle and hit on that particular obstacle and should once again come to the same position. So here and there. So there are 2 different journeys between the same gap. So in order to find out the original gap, we need to divide the total distance traveled by 2. Okay. So the total distance is 33 meters. You need to divide it by 2. Then we can get the answer as, the near answer as 16.5. So this is the minimum distance in order to observe the echo. In order to observe the echo, the minimum distance needed is equal to 16.5 meters, my dear children. 16.5. So if it is greater than 16.5, you can hear the echo very well. However, my dear children, if it is in kilometers, like few hundred kilometers, then we won't be able to hear the echo. Why is that? Because, my dear children, when the sound waves are going to travel to a certain distance, the intensity of the sound is getting reduced somewhat, because the sound vibrations are getting absorbed from the factors in the environment, okay, or from the materials in the environment. These vibrations are getting absorbed, okay. So this sound energy, right, there is a certain distance which the sound energy can travel. So if it is in few hundred kilometers, then you won't be able to experience the echo at all because of the too much distance. Like 17 to 18 meters, then you can clearly hear the echo without any trouble, right? So this is how that 16.5 meters come as the minimum distance between the obstacle and the observer to observe the echo, right? So these two key facts are very important. What are those? The sensation of the sound which is retained in human ear, actually it should be the brain, is equal to 0.1 second. And the second one is sound is going to travel at a speed of 330 meters per second in normal dry air. This is the average value. Okay, so by using these two, we can calculate the minimum distance between the obstacle and the observer in order to observe the echo. Right then, reverberation. Our next topic is reverberation. So reverberation is very simple. Even I have introduced this thing to you guys, my dear children. Reverberation. So reverberation is the process of recreation or else reflection of the sound. It's getting re-reflected. The same sound is reflected several times and comes to us. Okay, so that is reverberation. So let's see. There are some instance in an auditorium or else a cinema hall that the sound emitted by the loudspeaker is not clear. The reason for this is that the echo generated by the reflection of sound is heard before the initial sound fades off from the ear. Now in here, my dear children, what will happen? The reflected sound is heard by our ear or observed by our ear before the losing of first sensation in our ears. So the brain will get somewhat confused, right? Several sounds are going to come at the same time before losing the sensation of the previous ones. In that case, my dear children, brain will get consumed and it will not be able to clearly identify the sounds, okay, information in the sounds expecially. So here it is given. Final result of this is that the observer experiences a mixed unclear sound, right? Here the observer, right? It should be observer, my dear children, over here. Here the observer experiences a mixed unclear sound, right? Here the observer is going to experience a mixed unclear sound, okay? The persistence of sound for a long time because of the disability to distinguish the original sound and the echo is known as reverberation. So reverberation is the echo which is going to happen repeatedly, my dear children. However, this echoing process is heard or is sensed by the person or the observer before losing the sensation of the first sound. Okay, so therefore the observer will not be able to identify these two sounds as two different sounds. So what will happen? Persistence, right? Persistence of sound for a long time because of the disability to distinguish the original sound and the echo is known as reverberation. So reverberation is the disability to identify two different sounds, disability to identify two different sounds as two different sounds, because of the persistence of the first sound in our ears. So this is referred as the reverberation, reverberation. Okay, then reverberation is a disturbance for clear hearing. So like I said, my dear children, it's a disturb. We won't be able to capture the information contained within the sound wave because of the reverberation. In a cinema hall, in an auditorium, if a certain person is going to give out a speech in a cinema hall, if the movie is giving out a certain dialogue, then we won't be able to capture their sounds very clearly because of the reverberation. So it is a disturbance for us. So therefore, methods are used to prevent the reflection of sound in auditoria, lecture halls and cinema halls where clear hearing is expected. So my dear children, in order to experience the clear sounds, what will happen here? Here the new methods or else some remedies are being followed in auditorium and in cinema hall in order to reduce the reverberation process. It's very important to follow out these things in order to reduce the process of reverberation. Otherwise, we won't be able to capture anything. So, it is given here, reverberation occurs because of the reflection of sound. Reflection of sound can be minimized by making the surfaces that sound strikes to absorb it. Then the next thing is that you know that reverberation is going to occur because of the reflection of sound. However, I told you that, my dear children, their objects can reflect sound and as well as they can absorb it. Here we are, if we are going to increase the roughness of the surface, then the absorption is also going to increase. If we can make the surfaces somewhat porous means that the surface is not continuous, it is having somewhat whole kind of structures. In that case, sound will travel, and within the porous structure, my dear children, the absorption is going to be high. So in that case, what will happen? In that case, my dear children, the reflection is not going to occur very well, I mean, like, clearly it's not going to reflect. Okay, the sound will be absorbed by the certain surface. So by that way, we can reduce the reverberation. Thus, the reverberation can be prevented. Following methods are used in places like cinema halls, auditoriums and studios to absorb sound and thus prevent the reverberation. So now let's see what are the methods that we can use to prevent the reverberation process. It is given that in the slide, my dear children, that we can minimize it. But let's see what are the things that we can follow to minimize in the next slide. So here you are given with the methods which can be used to minimize the reverberation. First one given, making the walls rough. So like I said, making rough, making porous. Those are the two steps that we can take. By making rough, we are going to allow the sound to absorb quite well onto a certain surface. So when making the walls rough, it's going to absorb the sound. So in that case, the reverberation is going to reduce because the reflection is not going to happen well. Next one, making the ceilings porous. So the top ceiling, we are making it porous. Okay, in that case also, sound is not getting reflected very well. Okay, Then the next one, hanging rough folded curtains. Rough folded ones. That means sound absorption is going to be very high by those curtains as well. Okay, so two things that you can do mainly in order to avoid reverberation. First thing is making a surface porous. Second one would be making the surface rough. By using these two processes, okay, or else these two main methods, you can avoid the reverberation up to a certain extent. Okay, my dear children. So these are the methods that we can use to minimize the reverberation process. Okay, reverberation process. Right then you are given with a fresh new topic. So within this fresh new topic part, we'll be discussing the instances where the reflection of sound is applied usefully. What are the places that we are going to apply this reflection of sound? Okay, what are the places that we are applying this reflection of sound? So my dear children, let's see. First thing is given ultrasound scanning. Ultrasound scanning. Okay, let me give you a brief about the ultrasounds. So we discussed about the ultrasounds in grade 8, my dear children. Okay, and also when we are discussing about the human ear, we discussed that there is a certain range which is called as the human audible range. Okay, in hertz there is a certain amount of hertz which we can hear. So a human ear can hear up to 20 to 20,000 hertz, between 20 to 20,000 hertz. Sounds that has the frequency more than or greater than 20,000 hertz are the ones which are referred as, right? Those are the sounds which are referred as ultrasounds. Okay, ultrasounds. Sounds that has the frequency of greater than the maximum limit of the human audible range, right? That means beyond 20,000 hertz. So you know that the frequency is measured from hertz, right? Okay, so if the frequency is greater than 20,000 hertz, then my dear children, that particular sound is referred as an ultrasound wave. So reflection of ultrasound waves is used to observe the shape of internal organs. In order to observe the internal organs, we can use this reflection of ultrasound waves. So when ultrasound waves are reflected, right? When ultrasound waves are reflected, my dear children, by using a machine or any kind of an instrument, we can graph the structure of the tissues and the and especially organs. Okay. So this is carried out by certain instruments and machines. Like in here, we are going to take a scan report, same as or similar to the X-rays, right? So let's see, here it is given. So this method is known as the ultrasound scanning. Ultrasound waves are generated by a machine and are aimed at the relevant organ, right? So aimed at the relevant organ. So here the specialty is that in the ultrasound scanning, the ultrasound waves are which are generated by a machine and aimed at the relevant organ outside the body. Now, from the outside, we are aiming that ultrasound wave towards our body organ. Okay, then what will happen? Ultrasound waves will come and hit on that particular surface, on the particular wall, right, wall of the organ, and once again it will get reflected. So by monitoring that, the machine is the one which is going to monitor that. It's going to graph down, or else it's going to draw the structure and the shape of the thing. Then ultrasound waves that reflect from the organ are received by the machine. Those waves formulate the external appearance of the relevant organ on a screen. So like I said, my dear children, these reflected rays are being processed by the machine, and after that, what will happen? These processed data is being converted into an image which is on the screen. So by that way, we will be able to observe. By that way, we will be able to observe the internal condition of the organ, right? Especially this technique is used in, right, in order to check the condition of the fetus, condition of the womb, especially in the pregnant mothers, my dear children, right? And sometimes in order to check the condition of liver, in order to check the condition of our kidneys, we use this specific method. It is because usage of x-rays for that most sensitive parts, right, or those most sensitive instances is not probable. X-rays are very much dangerous, pretty much dangerous. I mean, like here we are using radiation waves now. So these radiation waves can harm our DNA and our cells. So these cells can be mutated and cause cancers even. So therefore, usage of X-rays is pretty much harmful to our body, right? However, if there is no option, then we have to go for it. Okay, if there is no option, then we have to go for it, because we won't be able to get structures of the bones by using the ultrasound scans that well. In that case, we have to use the X-rays. However, my dear children, these things are very harmful. So therefore, in order to observe body organs, and especially in observing the structure or the fetus condition, we must use ultrasound scanning, right? Ultrasound scanning is the better process in here. It's because that those things are not that much harmful, right? Those things are not that much harmful. So here you are given with two instances. Womb of a pregnant mother is being subjected to ultrasound scanning. Then here, how the fetus developing in the womb is seen by the ultrasound scanning. So ultrasound scan is mainly used to observe the condition of pregnant woman and, my dear children, the condition of the fetus, especially and in other instances like the checking of the internal body organs, right? So this is the main use of, right, this is the main use of reflection of sound. Here we can use ultrasound waves. So these reflected ultrasound waves is going to create a certain image. Then by using this image, my dear children, we can get the condition of interior body organs and the condition of a fetus within a womb, right? Okay. Then, my dear children, the same thing is given within the extra knowledge part. X-ray photographing may be harmful to organs and living body, but the harm is very less in ultrasound scanning. So like I said, as these things are radiated waves, these things can harm our tissues and can damage our DNA. So mutated DNA and tissues will create cancers. So X-rays are somewhat harmful to our body, but however, the harm is very less in ultrasound scanning. Okay, harm is very less in ultrasound scanning. That is why most of the times we use ultrasound scanning to check our internal body organs. Okay, most of the times X-rays are being used to check the conditions of the skeletal system. Okay, skeletons. To check the conditions of the skeletons, we use the X-rays. However, X-rays are somewhat harmful, my dear children. Okay, right. Then the second use of the reflection of sound. Here is given, find in the depth of the ocean bed. Find in the depth of ocean bed. It is important to know the depth of the ocean bed in navigation. Reflection of ultrasound waves is used for this purpose. The method used is known as sound navigation and ranging, sonar. The depth of the ocean is determined by the time taken to receive the wave back to the equipment after reflecting from the ocean bed. Then the equipment used for this is known as the echo sounder, right? So there is another special advantage of reflection of sound. So that is to find out the depth of the ocean bed by a certain ship or else a machine that runs on water, especially in oceans. So here you can observe there is a ship. Now this ship needs to calculate the depth between the ship and the ocean bed. in that case, the ship is going to emit a certain ultrasound wave, and that ultrasound wave is going to come and hit the ocean bed and once again travel towards the ship, right? Then by calculating the time taken which is emitted, calculating the time taken in order to travel and hit the ocean bed, and once again the time taken to travel towards the ship, okay, the depth is being calculated, okay, by using the time taken for a particular ultrasound wave to hit on the ocean bed and once again come back to the initial position, right? The time, by using the time taken, the distance between the ship and the ocean bed can be calculated. The depth can be calculated without any trouble. Like the way which we calculated the minimum distance. Can you remember? We calculated the minimum distance between an obstacle and the observer in order to hear the echo. In the same way, right, the machine contained within the sonar system, right, the instrument used for this kind of purpose is referred as the echo sounder. So echo sounder is going to emit the ultrasound wave and it is going to calculate at how much of a speed which is going to travel, right? Then by using the time taken to reach the bottom and come to the original position once more, the depth can be calculated. So the equipment used for this purpose is referred as the echo sounder. The technology which is being used in here is called as the sound navigation and ranging, or the sonar systems, right? Sonar systems, sound navigation and ranging. Okay, so you are given with two figures over here. Ultrasound wave which is getting emitted over here, then should come to here. Then by calculating that one, by calculating time, right, the machine can calculate the depth. Okay, so here it is given how the depth of the ocean bed is determined by the echo sounder. Then within this figure, given how the information of ocean depth is depicted in an echo sounder. So here you can calculate the, actually it is been printed on the machine screen like this, like 15, 25 and so on. So this is how the depth of the ocean bed is calculated by a certain ship. Here also we use the reflection of sound waves, especially reflection of ultrasound waves. Right, my dear children. Now let's head on to see the next advantage of the reflection of sound. Okay, so this is the second advantage, my dear children. Here, to find out the ocean depth of the ocean bed, right, in sonar systems, the instrument called echo sounder, it can be used. Now let's head on to see the next one. For bats to identify obstacles at night. Okay, so you know that bats are nocturnal organisms, okay, nocturnal animals. That means they come out at night. Means that their eyesight is somewhat different than us. Actually, these nocturnal organisms, or else nocturnal animals, they are going to navigate not by using their eyesight, but by using the ultrasound wave reflections. How come? These animals can emit ultrasound waves, especially bats. So once they are going to emit these ultrasound waves are going to hit on a certain object or else hit on a certain obstacle, and once again those things are going to come towards the observer or this particular organism. So my dear children, bats are like born mathematicians. I mean, like, they have the ability to do the math very quickly so that they can locate or else so that they can decide like how the obstacle is like how much far away from him, okay, or else the bat. Right? So within their mind they can do the calculation. Actually that is not the one, I'm just humoring you guys. So naturally they have that ability to determine. They are not going to do the math part, but however they have the natural ability to do, right, this kind of a thing where they are going to do the, right, they are going to do that certain type of a calculation. Not actually they are not going to calculate, but however they have the sense in order to get a certain idea about the distance between the obstacle and the bat. Okay, so this sense is coming mainly because of the reflection of sound waves, especially reflection of ultrasound waves emitted by the certain bat or whatever the nocturnal animal, right? So for the navigation of the nocturnal animals, these ultrasound waves are very important, right? Because you know that if there is no light source, then we won't be able to observe the things, my dear children. There should be definitely a light source, a source of light. However, during the night, there is no light at all. Sometimes there is no light at all. It's very dark and we won't be able to identify the things even there, right? So my dear children, even though we can't observe those things, nocturnal animals can observe without any trouble, because most of these animals are going to use they're going to use ultrasound waves for their navigation. Okay, so here it is given. Reflection of ultrasound waves helps nocturnal animals like bats to identify obstacles at night. Ultrasound waves emitted by them reflect after bouncing on the obstacles, right? So these ultrasound waves, they're going to hit on a certain surface or else an obstacle, and once again these ultrasound waves are coming towards the emitted source. By that way, the particular animal can decide like how much far is the obstacle. Then they can navigate without hitting on the obstacle, right? So that's how these bats and other nocturnal animals navigate during the night, or else otherwise they won't be able to navigate, my dear children. You know that, like I said in the previous, if there is no light source, at least there should be very small amount of light in order to observe obstacles. However, these guys means these bats, they're going to navigate by using ultrasound waves, ultrasound scanning process. Actually, it's not a type of an scanning. Here they're going to emit the ultrasound waves and they're going to emit that ultrasound wave. Then it's going to hit on a certain obstacle and once again come back to the bat or whatever the nocturnal animal. Then by deciding the time taken, right, the bat or the other animal can decide like how much far is the obstacle. Then by that way it is going to avoid the obstacle, right? So not only for the nocturnal animals, my dear children, sometimes for the navigation of whales, for the communications of dolphins, right, these ultrasound waves are quite important. Okay, it has been examined that most of the times dolphins and whales, they are communicating with each other by using these ultrasound waves. Dolphins are somewhat like, like strange kinds of animal. I mean, if you take the abilities of dolphins, they have different abilities, right? Dolphins can even travel like 300-400 kilometers without getting lost in the environment. I mean, like they are in the oceanic environments, no? So however, no matter they are going to travel like several kilometers, they can come to the same place without any trouble. It's mainly because they are using ultrasound waves in translocating. Okay, so that's about the dolphins. Now it has been studied that nowadays by the scientists, for the communication of these organisms, especially whales and dolphins, these animals use these ultrasound waves. Okay, even dolphins can emit ultrasound waves within the water. So unlike the air environment, my dear children, like I said when I was talking about the sound lesson for the first time, right? I mean, in the previous chapter, I think you could remember, we discussed that sound is going to travel way more faster in water and even more faster in solids. So because of the rate of transmission of sound waves through these watery medium, they have even more benefits. These whales and dolphins, they have even more benefits. Okay, so my dear children, not only for the nocturnal animals like those and organisms, whales and dolphins, they also use these ultrasound waves in different kinds of applications. Okay, remember that. Then here it is given, ultrasound waves emitted by them reflect after bouncing on the obstacle. According to the time taken, right? According to the time taken for this, they can determine the distance to the obstacle. So here you are given with a figure of a bat. As you can see, how the ultrasound waves are emitted by the bat and it is getting reflected after bouncing back on the obstacle. So this particular bat is going to emit the ultrasound wave, then hit on a certain surface, then once again it is going to come towards the bat. So by taking the time taken, right, in order to receive the ultrasound wave, the bat is going to determine the distance between the obstacle and the bat. Okay, so this is how they are navigating in night, my dear children. So this is the third use of the sound reflection, especially ultrasound reflections. Okay, right. So we have studied several things regarding the ultrasound reflection, my dear children, within the final lesson part of this chapter. Okay, now by that I'm going to finish up the chapter, my dear children. So here mainly we discussed about the benefits of sound reflection, and we studied about the reverberation and as well as the echo. So within our next chapter we'll be starting a fresh new lesson part which is regarding the refraction of light. Okay, but however, let's discuss that thing in our next chapter.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.